dun. We're talking about the rock cycle today. Okay. Which of the lists here in Pear Deck correctly shows the three main types of rocks? The names of them. Is it A, volcanic, sediment, and fossil? B, igneous, sedimentary, and metamorphic? Or C, crystal, mineral, and sand? Let's try to get a few more people in the Pear Deck. It should be working okay today. I'm a little sad about our vacation because we're not taking it up, obviously. Um, but yeah. Okay, so it looks like most of the people who have entered responses have it down. It's igneous, metamorphic, and sedimentary, or sedimentary, depending on who says it, what country you're in. Damien, what's up?
Yeah, I have a picture I want to share that I made yesterday. Is
Yeah?
it alright if I do that real quick?
Yeah, go for it.
I wrote in Japanese too.
That looks really good.
Yeah,
Yeah.
see,
What is
I did Japanese.
Oh,
what does it
neat.
say? What does it say in English?
It's people from One Piece, like Monkey D. Luffy, Garp, and a lot of other
Oh,
people.
okay. I've never seen One Piece before.
It's Mecha Godzilla, but I decided to add some of my own things. I even added the Apex Cybernetics name. I even put their logo.
Nice. That's pretty cool. Thank you for sharing. Orion, you wanted to add something?
No, I was just gonna try to answer this question you just gave. I think
Okay.
it's every single rock, I believe, on Earth, the main rock is sedimentary.
That is not the case,
Oh,
unfortunately. That is one of the three types of rocks,
yeah.
and we're going to
But
get
what's
into what makes how we classify them.
yeah, but which one is like if you combine them all together, like the main rock, what would that be called?
I think
Like the
that's
main
metamorphic.
So, like, which category has more rocks in it, or that are here on Earth?
yeah, like all yeah.
That's a great question. I don't know. I don't know. Okay, so we've got these three types of rocks. We've got igneous rocks, metamorphic rocks, and sedimentary rocks. Igneous is right. Igneo means fire. Okay. So igneous rocks are rocks that came straight from lava or magma. Okay. So remember, magma is called lava when it comes out when it's over on top of the surface. Okay. Um, Igneous rocks, again, they are the dried lava. That's what happens. Or dried magma, cooled rather than dried. Um, they're pure, more pure if you think of it. Sedimentary rocks are broken up pieces of rock and other materials that have kind of gotten glued together over time. And metamorphic rocks are one of these other two that have been changed over time from pressure and heat. Okay. So when you add pressure or heat or both to something, it's going to adjust how those molecules and atoms are aligned, right? And that's how you get these metamorphic rocks is by adding pressure or heat to one of these other two categories. Okay. Um, we've got the sedimentary rocks show it. It's not really a show it, it's more a quiz. And then the checkpoint 5.2 this week. Okay. So let's talk more about igneous rocks. Igneous rocks are really cool. This is how all rocks start here on Earth. Dried magma or lava, or cooled magma or lava, I'm sorry. Um, you can see the crystals in some of them. And a lot of the granite that you see out here in the Sierra Nevadas is igneous rocks, right? Granite is a type of igneous rock. Um, okay. The let's see, in Yosemite, I don't know if you guys have been to Yosemite. It's beautiful. It's really close by. Ask your parents to take you if you haven't gone. Okay. But all of those big formations are granite from dried magma and lava and was pushed up to the surface a long time ago. Okay. The largest igneous intrusion is called a batholith. A batholith. Sounds like a Spanish person with a lisp. You know how they say Ibiza. So the batholiths in the Sierra Nevadas, okay, or a batholith in general, okay, is when a big chunk of magma is pushed up and intrudes, or a batholith. A large batholith in the Sierra Nevadas is about 400 miles long and 60 to 80 miles wide. Okay, and it's the core of the Sierra Nevada mountains. And when we do that, or when we see that, that's oh, my brain. Sorry, guys. When um when you get down to the rock, get through the trees and the dirt and everything in the Sierra Nevadas, when you get down to the rock, uh, that's when we see the batholith, the granite there. Um, let's see. So igneous rocks, we've got lots of different textures that you see in various different igneous rocks. Yeah, let's not talk about it, guys. Um, so you get a coarse grain texture, right? Where you can see a lot of the crystals. You get a fine grain texture where you can't really see the texture, the crystals. You have porphyritic, you have glassy, and you have vesicular. Okay, so vesicular looks like there's little tubes or tunnels in it. Okay, and we have really two categories of igneous rocks. We have intrusive and extrusive. Okay, and that just has to do with where they cooled down. Okay, so an intrusive igneous rock is magma that cooled. An extrusive igneous rock is lava that cools. Okay. The faster the rock cools, the less time the crystals have to form, right? The less time it has to get the various atoms into place. Okay. Um, so the faster it cools, the more glass, the fewer crystals you'll see. Sometimes it cools so fast that air even gets trapped in, and that's where you get that vesicular texture, like in pumice. Okay. So let's do a little question. Where are you more likely to find a large amount of igneous rocks? On the beach, in a canyon, in a volcano, or by a volcano, I guess, or in a swamp? Which of these locations are you most likely to see? Please answer in the Pear Deck. Okay, we got most of the people responding are saying in or around a volcano. That's correct. Next, the rock below is often used in spas to exfoliate feet. What type of rock is that? What type of rock is that? Yes, most of you are correctly identifying that as an igneous rock, right? That's pumice. Okay. Thomas, you are fine. It took me, like, I was trying to get the thing removed and it was taking way too long. Yes, igneous rock. It's pumice. Okay. What type of rock is shown here? What type of rock is that? So this would actually be an igneous rock, guys. And what gives it away is that you see crystals. You see crystals that have formed. Okay, so this is actually a type of granite. Orion, you got a question?
There was a question on the Paradox and in the show it that I didn't understand that one
Mhm.
of them has like animals in it. I'm trying to figure out which type of rock is it.
I think you're frozen, right?
We're not frozen. We'll talk about the animal one in a minute, okay?
Okay.
Okay. So the one we're seeing right now is actually um, an igneous rock. Okay, that's an igneous rock, and again, it's the crystals there that kind of that give it away. And so next we've got sedimentary rocks. Okay, these. Okay, we group these slightly differently, and we group them based on how they became rock. Okay, how the sediment actually got glued together. But this is sediment are just small pieces of rock that have, you know, gathered together. Okay. So rock gets eroded over time via various processes, and then it gets deposited and and flows down rivers and uh, drops at the delta and things like that. And then eventually, over thousands, tens of thousands, millions of years, it gets glued together. Okay. We call that compaction and sedimentation. Okay. Compaction and sedimentation. So compaction is when they get, or cementation, sorry. Compaction is when they get like squeezed together, and cementation is when they kind of get glued. Uh, and it's all kind of happens together. Compaction and cementation don't really happen separate from each other, but we do qualify them as slightly separate processes. All right. So check something. Looking for. So we group these sedimentary rocks into three categories. We've got, and again, it comes down to what we find in the rocks and how they got cemented together. What do you guys notice about these three types of sedimentary rocks? Yes, Evie.
They all look like crystals.
Ooh, they all look like crystals. Okay. What else, guys? What other observations? Adeline.
Kind of look like, at least the last two, kind of look like a bunch of stuff packed together.
Yeah, it looks like stuff, chunks smashed together. Um, Riley, what do you notice?
The first one, I noticed that like like those salt crystal things, like the ones that you can get like at the store like as a lamp. It looks like one of
Oh
those.
yeah, it does, doesn't it?
You
It
mean
looks
those
like
fake
that one on the
crystals?
left looks like a salt crystal.
Those little fake crystals?
Yeah. Adeline, what else?
I just realized the one on the left I used to have rodents and you would give them salt licks.
Yeah,
Or
and they look a
treats.
lot like that, don't they?
Yeah.
That
Awesome. Yes.
if these rocks are definitely all cemetery, but like the last thing you just showed us about rocks pressuring and all the water disappearing, like what happened in the dinosaur era, all the water disappeared and the creatures that lived underwater went to the ground, right?
Mm.
So and they hardened. What I'm trying to figure out is what rock type is that in the rock cycle. And some of these look like they all rocks can maybe fit things in them, but I'm wondering from these or types,
All
what was
all
that?
all three of these are sedimentary rocks.
Yeah.
All three of them. Okay. So we've got three categories of sedimentary rocks. We've got organic sedimentary rocks, which came from living things. It's organic sediment. You get plants and animals that are dead, that have been stuck in dirt and other rocks, um, and kind of get glued in there. That's where we get fossils from. We get fossils from these things. Um, okay. Let's see the other types. Okay, so an example of organic sedimentary rocks are limestone and coal. Okay, right. Coal is dead plants, dead plant material. Um, Limestone are frequently like the shells of Dead Sea creatures. We have clastic sedimentary rocks. And clastic sedimentary rocks are other rock chunks that have been glued together. Okay. Yes, Orion.
Hmm. So all these rocks are like, Now you said sedimentary rocks are crystals. Wait, because one of them
No,
we
no,
saw
no, no.
here,
Igneous rocks form
igneous rock.
crystals.
Well,
Igneous rocks.
the thing I'm confused is why is this one like second to the right? I meant left. Looks like it has
Breccia.
crystals in it.
So breccia, it doesn't have crystals, right? It has chunks of other rocks, which is not the same. Okay. The conglomerate, that does have some crystals in it, but those are igneous rocks that have been smashed together and stuck together within this sedimentary rock, right? So it's a piece of rock that formed from chunks of other rocks. Okay. So, but you don't see uniform crystalline patterns the way you do in an igneous rock. Does that help, Orion? Damien, you have a question.
Yeah, so you said that some rocks are made out of Dead Sea creatures.
Hmm.
I would like to add something to that if that's okay.
Sure, yeah. What?
So, the reason why they're stuck in there is because over thousands of years, their corpses, aka their bones or shells, accumulate. And since most of their bodies made out of cartilage, it comes together in the rock, and after a while, like a, like a couple million years, it
Mhm.
fuses with the rock. Eventually, we find a nice formed fossil inside of the rock or outside.
Yeah, so it's from materials like cartilage or bone, or an exoskeleton, right, like you said, that have that let it stick around long enough for those minerals, from rocks to kind of take their place. Yeah, good. Thank you. Thank you for adding that, Damien. Um, let's see. We also that's there is a third category, but and it's chemical, um, but we don't really have that in here. So let's look. Let's try to answer these questions. What type of rock are you more likely to find in this location? Igneous, metamorphic, or sedimentary? Adeline.
Sedimentary because it's like water, and water tends to press and carry sediments to air.
Yeah, exactly. Um, precisely. Okay, so this is where we would find sedimentary rocks. We got a lot of deposition happening here, a lot of erosion. Okay, what type of rock is pictured here?
Oh, did you know that these things are actually still alive? We call them horseshoe crabs. They're
These
still alive.
these are
Like,
not actually horseshoe crabs. These are fossils of trilobites.
yeah,
They-
but we still have a living kind of ancestor. Those are kind of like the. Wait, what crabs would I
Yeah,
say?
yeah.
Was I
Horseshoe
saying?
crabs do look similar to trilobites, yes.
Which is why we end up calling them basically the same genome.
Um, that would have to do with their DNA makeup, and I would have to look into that. Evie, what were you gonna say?
I was gonna say it's actually a sedimentary rock because yes, those are fossils.
Yes. Yes, exactly. So the presence of fossils is a dead giveaway that it's a sedimentary rock, guys. Dead giveaway. Okay. We also have metamorphic rocks, right? That's when we get pressure and or heat. So it could be one or both. Okay. And those things change the molecular structure of the rock, of the sedimentary or igneous rock that was there. Okay. So the parent rock, the original rock, is either sedimentary or igneous, and then it gets heated up and squeezed, or sometimes just one of them, and that moves the atoms around. So you get something new, something different. Okay. And those are called metamorphic rocks because to metamorphosize is to change. Okay. We have two kinds. We've got contact and regional. And basically, it's just how close was this heat or pressure to the rock that changed. Okay. If it was touching, right? If it's touching the heat, you're going to see a different kind of change and a different kind of resulting rock than if it's just close to it. Okay. Um, we've got, oh, there's the chemical sedimentary rocks. I don't know why that's so far away. I'm sorry. I'll fix the order of that. So there's chemical sedimentary rocks. When a chemical, what's the word? Reaction. Wow. When a chemical reaction happens in water and then a new substance precipitates or falls down, that creates a chemical. That's what we call a chemical sedimentary rock. That's how we get a lot of salt, right? Like those salt crystals, like you guys mentioned. Orion, what's up?
If like chemicals like that, like some rock, like in one of the questions, it might show it. I saw one that talked about like it looks like a sponge,
Mm,
like the how do like I've been trying to wonder if it's a metamorphic rock or a sedimentary rock.
it's neither. It's neither, right?
No,
So that one that looks like a sponge is called pumice, right? And so it's those presence of air holes that tells you, okay, that it's an igneous rock. The fact that air got trapped in the rock means it cooled super, 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 super fast, right? The air didn't even have time to escape. Okay. Metamorphic rocks don't cool that fast. They can't.
thank you.
Yeah. Okay, so we've got two kinds of metamorphic rocks. We've got foliated and non-foliated. Basically, do you see a folded, wavy sort of pattern or not? That's really all that comes down to. Um, Foliated, you get tend to have a lot more pressure, right? Because again, it's folding the rocks over, and you see those lines and those bands. Okay. So, some examples here. Right, metamorphic rocks have parent rocks, right, that are either sedimentary or igneous, and we can usually identify what the parent rock was because the chemicals, the atoms that are there, are still the same. They're just in a different arrangement, right? So, limestone, when it gets around heat and pressure, will turn into marble. What about coal, guys? If coal gets under heat and pressure, what happens? What does that become? Right, coal is an organic sedimentary rock, but it can metamorphosize. Any ideas what coal metamorphosizes into? It metamorphosizes into diamonds, guys. Diamonds. Okay, so what rocks form from pre-existing rocks due to intense heat and pressure? Okay, yes, metamorphic. Good job, guys. Good job. Okay, so what type of rocks are shown here? My puppy's asleep.
Hi,
What
Jenny.
what type of rocks do we see here, guys?
Oh, can I answer?
Yeah, go for it.
Well, it looks like metamorphic, igneous, and sedimental. Sure.
These are actually all metamorphic rocks. Okay. So some giveaways here. Do you see the striations or the lines in the one on the left and the dark black one? Right. We've got in the whitish one, it kind of looks like it's been melted, like a candle melted together, right? And the one on the right, also, you don't see a lot of tiny crystals or anything, right? So you generally see these sorts of patterns from metamorphic rocks. Okay. Now, we've got the rock cycle. That is all the vocabulary terms involved with moving from one of these types of rocks or its intermediary stages to another. Okay. So you've got cooling, right? That's solidifying, cooling. When magma cools or lava cools, you get an igneous rock. Okay. Um, when an igneous rock melts, it becomes lava or magma, right? It can go back and forth either way. We've got sediment, right? Sediment are the broken tiny pieces of rock that go through compaction and cementation to become a sedimentary rock. Um, when you weather, when you weather rocks and erode them, you can weather any type of rock and it'll become sediment, and then it can become a sedimentary rock. Okay, so it's all just how these, the process is getting from one to the next, those vocabulary terms.
Sorry for my screen changing all the colors. I'm trying to plug it up, but the charger's acting weird.
Oh, you're good. You're good. You're good. Okay, so let's see if we can identify the processes here. So we've got this cycle picture of the rock cycle. What process that causes metamorphic rock and igneous rock to become magma? Actually, it can happen to sedimentary rock too. So, what's the process that changes rock back into magma or lava? What's that process called? Is it erosion, melting, pressure? Erosion, melting, or pressure? Orion.
It is melting.
Yes, it's melting. Well done. Okay. Here's this diagram. Okay. We have
Thank you, Damien.
the different types of rocks in the rock cycle here, but we haven't named them. So which one's which? So number 1 is igneous, number 2 is sedimentary, number 3 is metamorphic. Which numbers go with which letters? Okay. Is igneous A? Is igneous B? Is igneous C? So and it tells you how they form there underneath that type of rock.
A is igneous.
Okay. So Damien says A is igneous. Do you guys agree with that?
Yes.
Okay.
Absolutely.
What would B? What would B be? Would B be sedimentary or metamorphic?
Metamorphic.
I
Ooh,
agree with Orion.
Sedimentary.
it's sedimentary actually, right? It's sedimentary, right? Because it occurs from weathering,
Well, you tried your best,
transport,
Orion. I
deposition.
probably wouldn't have gotten it either.
Yeah.
It's
So
okay.
You want to look, to identify whether it's metamorphic or sedimentary, you want to look for those key words like weathering, cementation, compaction, heat, pressure, right? If you have heat and pressure involved, it's a metamorphic rock. If you've got compaction and cementation involved, it's sedimentary. Okay?
Meaning A is igneous.
Yes. So A would be igneous, B would be sedimentary, and C would be metamorphic. Okay, we do have the booklet here. We're out of time though. I know that a couple of you really wanted to do the booklet. If we hadn't been interrupted by those Zoom bombers, we would have been able to. I really hope you guys have a fantastic Thanksgiving week. I'm
So
excited
do
for
you.
mine. Thank you. Thank you for being here. Thank you for your patience. I apologize for that Zoom bomber. Nobody wants to see or hear that stuff, you know? Ugh.
Have fun on your cruise.
Thank you so much. Have fun getting your tree tomorrow, Riley. Oh, you want to say bye to everybody? She woke up. She wants to say bye.
My tree is already up.
Bye.
Nice. Say bye, Kenny. Say bye.
Bye. Have a blessed day.
You
Bye, Chloe.
too.
Bye.
Bye,
Edie.
guys.
Have a.
Can I
hope
have
you
the
and your
exit
dog-
ticket link?
Yes, I will put that in the chat, guys. Just
I do hope you and your dog have a